Today we're going to be talking about how academic language looks like in math. First, I want to show you the definition of what the TPA is looking for in academic language for secondary math, and it defines it as language demands, and it describes it in five components as a function, vocabulary, discourse, syntax, and mathematical precision. So that means that academic language and language demands has these forms as a function, vocabulary, discourse, syntax, and mathematical precision. And we're going to go through all of them. Again, there's going to be one, two, three, four, five components. So functions, this would be the language functions. And as you can see, this is where it would appear these functions would correlate with the learning objective and would go in the language function of the lesson plan template. The definition for it would be the purpose is for which the language is being used, and they're usually in the form of active verbs. Like for example, and you see in the examples we have compare, explain, and describe, and they also have to be accompanied with something with vocabulary terms, which we'll see in the next component. Which, like for example, it says compare. Compare what? Compare the lengths. Compare functions. Compare different mathematical terms that we're working with in that unit. Explain, what are we explaining here? Explaining the strategies that they're using to solve a problem. They're describing the attributes of a parallelogram. And an activity that I wanted to address was one that we do and that we learn in our math methods course, where we have the students before they start the worksheet, and so we can ensure that what we're looking for, they find what we're looking for. And it's to first, for step one, they would circle all the verbs. So this would be all the language functions. For example, previous slide, which would be compare and explain. So whatever that worksheet is asking for them to do. And then step two would be compare what. So step two, they would underline the adjective. Comparing the function, what are we comparing here? The functions, the units, what are we doing here? Step three would then be to now pair them up to see which ones um, are corresponding together. For example, in the one below it, it's determine what. So they were circle, determine, and then they were underline formula because they had to determine the formula, and then again they would have to circle, solve, and underline area. They're determining the formula and they're solving the area. Another one would be language function would be verify. What are they verifying? Their statement and also and stating which identity they're using. As an example, in the bottom, these are some trig identities they have to use to verify that both the left hand side and the right hand side are equal. Next, as I said, would be vocabulary, and this comes in three forms. What I like to think about this one was one of the articles that we read for Dr. Matas, where it was just type 1, type 2, and type 3. And I believe there were, I think for here, so number 2 would be type 1, would be just like general words, and then number 3 would be like type 3, so words that are just super specific for that math, for that for the math classroom. For example, exponent, numerator, denominator, equilateral, and it also includes symbols. For the first one, which was words and phrases with subject specific meaning that differ from meanings used in everyday life, would be like table, ruler, square, face, chord, digit, times, and set. For example, table, they might think of it as, we're not really thinking about a physical wooden table, but a table to organize our data points. Another one would be kind of blocks. Some words do have double meaning in math, like we saw in one of the videos where this English language learner student saw a stick figure carrying blocks, but it was actually blocks like street blocks. Then it's discourse. So this is how students are talking, writing, and participating the knowledge construction. And this an example would be it comes as two column proofs, interpreting graphic representations, so identifying lines and when you graph ordered pairs. It also has distinctive ways of structuring oral or written language, like making and supporting a conjecture. So I think of discourse more like graphs using tables, a lot of visuals. Syntax would be the main function of it is to organize language in order to convey meaning. For example, right now in my tutoring, we're doing in my tutoring experience, we're doing expressions, and one of the common one that students get stuck in was the difference between a number and five. And for so that one they would have to underline difference, number, and five. So we know it's going to be five minus x or x minus five. So this is organizing the language, organizing the sentences or phrases to visualize or represent something. An example that they did provide for us was like using greater than or equal to. So six is greater than or equal to four. And also this one here, I like this one because these sentences are usually incorporated into math word problems. Also, conditional sentences, like the last one you see right here, where it's 50% of a number is 25. What is 75% of that number? So I believe like so here with the number, they would have to identify it as X. We don't know what it is. They would have to underline 25 and then 50% and then see what that turns into. Then we have mathematical precision. So this is actually having students being precise and accurate with definitions and symbols. And it comes when we're labeling stuff with graphs or we're measuring stuff, and we need to make sure that the students know what units we're working with, and they also have to know when to convert one unit to another. We can't be working with different units here, or else it won't work out. Another thing that came up when I was looking at mathematical precision was pi, and that pi does not necessarily mean 3.14 because the student used it in his online homework and he used 3.14 and it was wrong because it was approximately, it had to be an exact answer. So I feel like here a good example would be pi, that students need to know that they're approximating, that is not the exact answer. Another one that I liked here was correctly labeling the axis of a graph, which is really important when you're graphing ordered pairs. That's it.